you have to calculate the runoff. To calculate the runoff, there are several methods. Empirical formulas are there, and then SCS method is there, or rational formula is there. Okay. Once you calculate the runoff coming from the catchment, right, and to discharge that runoff, overall, if you ask me to explain in a very brief what is about this urban hydrology, is that first, for a given municipality or a city, you just, so this city or town, it falls in a catchment area. Okay, as I said earlier, so for any analysis, we should consider the natural boundaries, that is the catchment area, not the political boundaries. Okay, so in that catchment where your study area falls, first identify the a design star. Okay, how do you identify the design star? Based on the previous historical data of the rainfall data. Okay, so once you identify, for that there are several procedures are there. Okay, uh, as I said, we have already discussed that IDF curves, intensity, duration, frequency curves, right? So for 5-year return period, 30 minutes duration, what is the intensity of the rainfall? So first you have to prepare the IDF curves for the study area, and then identify the star. Okay, so for that star, that is the input to calculate the runoff. Okay, so once you calculate the runoff, divide the study area into different subcatchments. Okay, and calculate runoff coming from each subcatchment. Okay, so to discharge that amount of volume of runoff, okay, you have to design the pipe, right? So that is the basic idea. So for all this exercise, what data you need? First, you should need the contour data also. Contour data is what? Contour is what? Line joining the equal elevation. Okay, so you have to first do survey for entire study area if that data is not available with anybody, any agency. So if that data is already there, you can take that data. Okay, so based on contour data, we will divide the entire study area into subcatchment. Okay, so subcatchment means what? You know what is the definition of the catchment? The catchment has a single outlet, right? Rain falling on that catchment lives through a single point. Okay, so like that you have to decide. It's not like that rain falling on ward 1 of that Kakinada municipality will flow in a single outlet. It's not like that. Okay, so the catchment, subcatchment is also based on your contour data. Okay, so you have to divide the area in such a way that so uh, rain falls in that catchment area. Okay, goes away through a single point. Hello, is it audible? My voice is audible?
Audible, sir.
Okay. Okay, right. So you cannot divide the catchment abruptly, just like this is a subcatchment 1, 2, 3, like that. Okay, so so there should not be, say for example, if rain falls on subcatchment 1, it cannot flow to the subcatchment 2. Okay, it it only flows through outlet of the subcatchment and join the this drainage, I mean pipes. Okay, so for that we need contour data. Okay, so to calculate the runoff, we should know the land use land cover of the study area, right? Because land use land cover influence the infiltration capacity, right? So if it is an impervious soil, infiltration will be less. If it is a pervious soil, infiltration will be more. If it is a vegetation, then different. Okay, if it is a barren land, then it is a different, right? So like that, if it is an agricultural area, then it will be different. Okay, again, it all depends upon the soil also. Okay, type of soil. Okay, if it is a sandy, then infiltration will be more. If it is a clay, infiltration is less. Okay, so all these type of data first you have to capture. Okay, so that data may be in a spatial form using a GIS format. That how you get that data, either do manual survey or take the satellite data and derive this input. Thematic layer. Thematic layer means it represents one theme. Okay. Similarly, if you have a rainfall data at different locations, right, then we can do the Thiessen polygon method using spatial data and calculate the average rainfall over the study area, right? So like that, there are a lot of data you have to build before run the model. Okay, so this is just a brief where you can say the abstract of the what this urban hydrology is. Okay, so therefore, as I said, the data is very important. Contour data. So generally, if you go any municipality, they won't maintain this type of data because all Survey of India topo sheets. If you see it, Survey of India topo sheets, then you can see 100-meter contour interval, 10-meter, 20-meter contour interval. Okay, but that course scale, course scale means the vertical interval, 5 meter, 10 meter, does not serve any purpose in urban hydrology. We should have very fine scale, like 0.1 meter vertical interval data. Okay, so that so therefore the contour, what I am trying to say is this contour data you cannot derive from the Survey of India topo sheet for this type of study unless you have to do manual survey. Okay, because this is the contours. Generally, if you see the Kakinada urban municipality, the vertical difference between the highest point and the lowest point is very less compared to some other areas. Okay, so therefore, if you draw 1 meter contour interval, so you will get very few lines, 1 meter contour interval. Okay, so that's why we should have a 0.1 meter or 0.05 meter contour interval. Okay, then only we can do analysis for especially areas like Kakinada city. Okay, if it is a Vizag, then maybe 1 meter contour interval may serve the purpose because the relief means the difference between the highest point to the lowest point is called relief. Okay, that may be the high in case of Visakhapatnam compared to the Kakinada because it is a plain area. Okay, so say already some studies they said the Mumbai is preparing a contour map of the city at an interval of 0.2 meter, while Chennai is preparing 0.3 meter contour interval, right? Next is the rainfall requirement. Okay. For design of drainage system, the conventional practice is to choose appropriate statistically relevant design storms to establish the storm water flows to be conveyed based on existing national and international practice. Design storms can be estimated from the rainfall data records where available. Okay. There is a wide variation of rainfall among the cities and even within the cities. So rainfall shows large spatial and temporal variation. For example, Mumbai on 26th July 2005 at Colaba recorded only 72 mm of rainfall, while Santa Cruz, which is 22 kilometers away, recorded 944 mm in 24 hours. Okay, So another requirement. So now we have seen the requirement of elevation data, contour data, and another requirement for the model is the rainfall requirement. Okay. So this rainfall requirement, as you know, it is very spatial variation is very high and temporal variation is very high. Spatial variation is means sometimes you will see rain at Banugudi Junction, and you won't see rain at Sarporam Junction. Okay, such type of situation also arises sometimes. Okay, so that one example is that on 2005, 26th, in Mumbai, in one area there is only 72 mm. In the same city, in some other area, the difference between these two is 22 kilometers, 944 mm. See how the difference is. Very, very huge difference is there. Okay. So all those things you have to be considered. Some, I mean, a spatial variation and temporal variation also. Okay. And also, as far as, because spatial variation is very high, so therefore your rain gauges, network of rain gauge should be very high. The density of rain gauge in a city should be very high. Okay, so to minimize the spatial difference, we should have a drainage density network, very high drainage density network. Means we should have a rainfall. For example, we want to model for a Kakinada city, so you should have a rainfall station at Sarpavaram, at Banugudi Junction, at Jagannathpuri Junction, all right, at the city center, at Temple Street, as many as possible. So therefore you can avoid, minimize the spatial difference. Otherwise, for example, this case study, say for example, if there is a rain gauge only in Colombo, and there is no rain gauge at Santa Cruz. See, only, so it requires only 72 mm. So if you take the 72 mm, but the same day in another part it is a 944 mm. Okay. See, that gives an error to the model. Okay, that is wrongly. You are estimating, underestimating the storm. Or sometimes, say, suppose if you have a rain gauge at Santa Cruz and you are taking the 944 mm, okay, but in other part it is only 72 mm, then you are overestimating the design storm. Okay, so therefore, what I am trying to say that if you have a rain gauges at many locations, and if you take that average of that, then the error causes because of the spatial variation will be minimized. Okay, so what I am trying to say is that you should have a thick drainage dense, rain gauge density network over the city, so that we can gauge, we can minimize the error. Okay, and you can represent almost a real picture. Right? So due to the high variability of rainfall in space and time, rainfall measurements are required at high temporal and spatial resolution from dense rain gauge network for the adequate design of new system and renovation of the existing drainage system. Okay, so up to date IDF relationships need to be used to maintain the design standards for new system and retrofitting replacement of old urban drainage system. IDF curves will be developed for each city based on the extraction of data from the raw data charts at 50 minutes resolution, and from AWS, it means automatic weather station, at 5 minutes resolution, right? So for each, for study, if each city, meteorological department or a concerned department should prepare a IDF curves, intensity, duration, frequency curves. So therefore, you have to continuously monitor the rainfall data over the years. Okay. Suppose you want to design the drainage system for a city, without this data, you cannot do anything. Okay. So therefore, continuously. You should have a rainfall records of last 20, 40 years rainfall record data you should have. So then only you can, calculate, estimate a design storm based on the IDF curves, right? So runoff coefficient for long-term planning. So all future stormwater drainage systems will be designed taking into consideration a runoff coefficient of 2, C is equal to 0.95 for estimating peak discharge using a rational method, taking into consideration the approved land use pattern of the city, right? So as I said, runoff from the design storm can be calculated using different methods. One is the rational method. Okay. So for the rational method, that is a Q is equal to CIA. C is the constant. Okay. So that constant, generally here he said that C is equal to 0.95 for estimating the peak discharge using the rational methods. Okay. So these are the some of the guidelines, right? Operation and maintenance. So design and design, designing of your drainage network is one part. Operation and maintenance is another part. Okay. So if your O&M is not proper, so though you have a good design system, so it will not work. Okay. So this is very, very important is the operation and maintenance of the drainage system. Proper operation and maintenance are crucial for any system to be functional to the designed capacity and it for durability as well. So most of the stormwater drainage and sewerage systems suffer to great extent for want of proper operation and maintenance. Both the major and the minor drains are equally affected by this. Okay, so generally people neglect the operation and maintenance, though the funds every year government allocates some funds for operation and maintenance of the drainage system. Okay, if that funds are utilized properly, okay, and the operation and maintenance work done properly, then you will have an effective drainage system. Okay, if though your network, sewerage network or storm drainage network, everything there in a city, if it is not properly maintained, okay, regularly after every, monsoon period, we have to clean up the pipes. Okay, if there are any clogs that you have to remove, any blocks that you have to remove, such type of maintenance work, if any sedimentation deposition is there, that you have to remove. So any breaks that you have to you have to repair those breaks. Okay, and sometimes some gates, something like that, if it is not functioning, you have to replace that. Okay, complete replacement of pipes. Okay, any joints. Okay, is there any leak between, suppose sometimes the water from the drain, sewerage will move into a storm water drainage. Okay, and all these pipes will be mixed up in some locations. Okay, so all those things you have to do maintenance before starting of the monsoon. Okay, so generally we have a monsoon for 4 months in a year. So before start of monsoon, you have to finish the operation and maintenance work. Okay, because we cannot do this during the monsoon period. Okay, because continuously rain falls. Okay, so it is difficult to do maintenance work during the monsoon. So pre-monsoon desilting. So this is major drains and nullas were originally waterways for rainwater to flow. Therefore, pre-monsoon desilting of drains had become an annual ritual. Okay, every year before monsoon, you have to do the desilting, right? However, due to large-scale urbanized and lack of required sewage system in place, sewage started getting discharged into these waterways. All the same, pre-monsoon desilting is a major operation and maintenance activity. it has been generally observed all over the country that this does not commence and get completed on time, and as such even the designed capacity are not operational. As a result of this, even lower intensity of rainfall results in flooding. Okay, so if you have not done proper O&M activities, so for which storm you have designed the capacity, so that capacity will be reduced because of the silt up taking place in a drainage, okay, in these pipes or nallas, okay. So because of that one, the capacity get reduced, okay. Therefore, even for a lower intensity of rainfall, so flooding takes place in a city, okay. So therefore, this is a very, very important O&M activity. Removal of solid waste. Solid waste disposal and its proper management have significant effect on the drainage performance. Most towns and cities have open surface drains besides the road, into which there is unauthorized public disposal of waste. Okay, these drains need to be cleaned on a regular basis to permit free flow of water. So generally, what people will do, public will dispose their waste on the roads, okay, and it will go into the drainage, and it get blocked, okay. So there should be a awareness, public awareness should also be there. So everything is interconnected. There should be a proper drainage system, a proper operation and maintenance activity, and there should be a awareness should be there in a public, okay. A law and order should be maintained properly. If anybody dump their waste, domestic waste on the road, he should be punished. Some penalty should be there, okay. uh, at the same time, there should be some designated locations where they can only dispose their solid waste, right. So all these things are interconnected, then only the city should have a proper drainage system, okay. Pre-monsoon desilting of all major drains will be completed by March 31st each year. Okay, so generally, when the monsoon will start, it will start in first week of June. Okay, uh, so therefore, everything, all type of operational maintenance, desilting, it should be done before March 31st. That is, of course, that is the end of the financial year also. Okay, all waste removed, both from the major and the minor drain, should not be allowed to remain outside the drain of the drain for drying. Instead, the wet silt should be deposited into a container and transported as soon as it is taken from the drain. Okay. So, what is this? Say the cleanup of major drains and minor drains. Then they just remove and keep just besides the major drains. Okay. So if that is happen again, if there is a small rain occur, again it will go to the major and minor drains. Instead of that, so once they remove, and that should be properly put in a container and transported to a suitable dumping yard. There only they have to dispose. Okay, so completion of work will be certified by representatives of local residents, welfare associations, slum dwellers association, municipal ward committee members, besides third party certifications. Okay, so there should be some responsible person should be there in every ward. Okay, there may be he may be a government employee, or maybe some voluntary organization. Somebody should certify, yes, it was this drain was cleaned up. Okay, so somebody should certify. Okay, otherwise what will happen, how the system will work without doing a operation and maintenance work. So they will pass the bill. Okay. So such type things will also happen in our country. Okay. So a suitable intervention in the drainage system, like traps, combinators, trash racks, can reduce the amount of solid waste going to the storm sewers. Okay, suitable interventions like traps. Okay, so there should be something like traps means it will allow only liquid flow into the drain. It will stop all the solid waste. Okay, communicators means it will just like it will I mean cut the major solid I mean solid waste into small pieces. Okay, so such type of things also be there in the system, right? Cleaning of minor drains will be taken up from the outlet end to upstream side. Okay, so the cleaning should be taken uh, up to upstream end side. Okay, okay, then only it will be effective. So aging system will be replaced on an urgent basis. So old systems will be replaced. Okay, a master plan will be prepared to improve the coverage of sewage system so that sewage will not be discharged into the stormwater drains, right? So for any city, there should be a master plan. Okay, so master plan means uh, for a 50, 60 years, right? How your city will look like, where are the I mean industrial area, where are the living area, where are the open lands. Okay, how your roads will be, how your drainage system will be. So everything should be planned in advance before 50, 60 years. Okay, so otherwise what will happen if that is not there for approval of any I mean any like nowadays we can see a lot of real estate business. Okay, so approval is based on the master plan only. Okay, so even for to construct a house, it should be based on the master plan, right? So if you have a master plan well in advance, okay, and giving approval based on this master plan, and there is a minimum error. Okay, otherwise what will happen, this drainage network or water supply network or storm network may get mixed up in some other places, right? Adequate budget will be provided to take care of the men, material, equipment, machinery. Special funds will be provided for the safety equipment of the personnel carrying out maintenance of underground man entry sewer. So this is very unfortunate is that even though we are very advanced in technology wise. Okay, so we are going into the space, launching so many satellites, very very advanced, but still to clean up the this waste in a sewer, man has to go. Okay, through a manhole. Even now also, even if you see the big cities like Delhi, even in small Kakinada also, a man will go into the this drainage system, and he is physically cleaning with his hands. Okay, uh, so that is very unfortunate. There should be some type of machinery should be there to clean up the drainage pipes. Okay, and equipment should be there. Okay, some safety equipment should be given to the people who are doing this service. Okay, so that is still we are lacking. Okay, even we will see some casualty if a man go inside, and some dangerous gases may harm the people. Okay, still that is there. Okay, so that is very unfortunate. There should be some latest technology equipment, some robots, some sensor system. So such type of technology should be adapted for the cleaning of this drainage system. Okay, uh, So that should be there in advanced countries, maybe there, but in India, yet to come this type of technology. Okay. City bridges, increasing road networks for the ever increasing urban population has resulted in the construction of a large number of flyovers and bridges. In many instances, due to the shortage of land, the pair of roads and railway bridges are located in major stormwater drains and rivers in the city. So these are known to cause backwater effects as such as 1 meter high and as far away as 5 kilometer upstream, thereby resulting in flood of the upstream catchment. Okay, so because of the uh, cost of land, so generally the public infrastructure will be built uh, in a rivers, roads, on a drainage, open drainage system, right? Because of that one, the cross-section area of the drain will get reduced, and there is a backwater effect. So there should be there approximately 1 meter high. Okay, so that will go away. Backwater will go away up to 5 kilometer. Okay, it causes some flooding in that area. Okay. All future roads or rail bridges in city cross drainage should be designed such that they do not block the flows resulting backwater effect. Okay, so you should design your public infrastructure in such a way that should not disturb the natural drains, right? So otherwise, this type of problem will come. City road levels. Plinth levels of the houses was historically defined with reference to the adjacent road level. However, a recent trend that has emerged in many cities is that the roads are being resurfaced without removing the older layer. As a consequences, over the years, the new road levels in many instances are now much higher than the uh, approved plinth level of the adjacent properties. So this prevents drainage of the house, and during periods of rainfall, stormwater runoff causes flooding of these properties even with lower rainfall intensity. So generally, what sometimes you will observe, uh, say, so if you old house, if you see the old house which were constructed 40, 50 years back, okay, so those house, the plinth level of those house will be much less than the road level. Okay, so why that is that? Because the road, if say every 10 years they will again construct the road. So what they do without removing the old one, they will again they will do on the same old road. So because of that one, what will happen, the height of the road will slowly increases. Okay, so because of that one, at one point of time after 40, 50 years, okay, so the road height will be much higher than the plinth level of the house. Okay, so this, because of this one, what will happen? So for a small amount of rain, the water on the road will go into the houses. Okay, so that is the one problem why flooding is taking place. Okay, so therefore all road re-leveling work or strengthening overlay work will be carried out by milling the existing layer of the road and recycling. Okay, so already if the road is there, you have to remove that one and again construct the new one, right? Drain inlet connectivity. It is seen that the inlets to the drain, the water from the road and the roadside drains are either not properly aligned or non-existent, so leading to severe waterlogging on the road. The provision of a simple connecting element, namely the drainage inlet, through which the water can flow from the roadside drain into the underground drain, can significantly reduce the water logging under roads. Okay, so what is this? There are some inlets are there. If you see on the road, on the right, on the either end of the road, we have a small inlet. Okay, So that whatever the water, I mean rain collected on the road will go into that inlet, through inlet, and then it will go to the main pipe. Okay, if that is not properly placed, or if there is any problem in that one, so the road get submerged because of the small amount of water rain also. Okay, infrastructure for stormwater management. Stormwater structures can be divided into groups: conventional drainage system and sustainable drainage system. Okay, stormwater structures can be divided into two groups. One is conventional drainage system, and another one is the sustainable drainage system. So let us see what is conventional drainage system. Conventional drainage systems are designed to remove rainfall from urban environment as rapidly as possible using drainage channels and underground pipes. In general, their main purpose is to avoid urban flooding. Okay, what is the conventional drainage system is are designed to remove uh, rainfall, excess rainfall from the urban environment as rapidly as possible. So using the drainage channels or underground pipes. So that is what conventional drainage system means, right? Different components of the conventional drainage systems are urban impervious surface, okay, and these conventional roofs and pavements collect water and transport it to the drainage network. They are usually quite impervious. Another component is the pre-treatment devices, can be used to improve the stormwater quality before it is transported through the drainage network. So even before transport through the drainage network, it should be pre-treated. Okay, pipe network collect urban stormwater and convey it as rapidly as possible to the outflow point or treatment plant. So these are two types of networks. One is combined with wastewater and separate. Okay, so structural detention of facility, underground stormwater storage tanks that can be used to reduce the runoff peaks and floods downstream. So this is another component. Okay, treatment plant. In the combined system, stormwater and wastewater are usually treated in a wastewater treatment plant before being released into the environment. Okay, so these are the some of the components of the conventional drainage system. What is that? It is a pre-treatment device. Even before transporting the stormwater into the pipes, it should be pre-treated, okay, and then supplied. I will transport it to the pipe. Okay, and the pipe network, another component. So what it will do, collect the urban storm water and convey it to as rapidly as possible to the outflow point or treatment plant. So from there it will send the storm water to the treatment plant. Okay, so there it will be treated before disposing into the rivers or estuaries, right? And the structural detention facility. So if you don't have the space, open space to store the storm water temporarily, okay, so below ground you can construct such type of detention structures, okay, where your collected storm water will be temporarily stored in the underground, right? So therefore you can reduce the peak of the uh, hydrograph, okay, and you can reduce the flooding on the downstream side, and then have a treatment plant. Okay, so these are the some of the components of the conventional drainage system. Okay, a roof is the covering on most upper part of a building, protecting it from rainfall. Conventional roofs are usually very impervious, so they convey urban storm water away quickly. So roofs can be a flat or sloping. Sloping roofs produces higher runoff rates. So this is how your roof will look like. Pavements are the surface material laid down in urban areas to sustain the traffic of vehicles and pedestrians, and include roads and walkway. In general, standard pavements are completely impervious and they do not allow water to infiltrate into the subsoil. So water is collected and introduced into the drainage network through the cups and gutters. Okay. So water is collected from the roof and also water is collected from the pavement, right? Okay. So this is the inlets. Okay. The water collected from the road will go to the main pipe through this inlet. So pre-treatment devices. So this is how the treatment will take place, right? So if you see, so this is how the treatment will take place. Okay, this is the catch basin inserts. Okay, this storm water will enter into this basin through this one. Okay, the solid waste will be, separated, okay, and the liquid will be discharged like this. Okay, so this is a hydrodynamic separation, how the solid will be separated. So the inlet is in one direction and outlet is in another direction. Because of this one, the whirlpool will be created in this basin. Okay, so therefore because of that one, the solid will be deposited at ground. Okay, bottom. So some type of screening devices, okay, to filter the solid, right? So this type of device also can be used. Okay. So these are the advanced filter system. So below the road, so we have this type of sand filters. Okay. So it will, there are 3 chambers. This is 1, 2, 3 chambers. So this is the inlet. From there it will water into this one. So here the all waste get deposited and then only water will be flowed to the third chamber. From there it will be disposed. So after monsoon, so this sediment will be removed from this chamber. Okay, such type of arrangements can be made. Okay, so this is also advanced filter system. Okay, this is how the your pipe network will be there in a drainage system. Okay, structural detention, as I said, temporarily you can store the water in underground. So this is how this storage tanks will look like. Okay, so this is the inlet, maintenance access. Some steps are there to go inside. Okay, so maximum detention volume up to this level you can store water, and then outflow. Okay, so this is the real picture inside. So this is a huge structural detention facility. This is the underground. Okay, where here water is stored. Okay, treatment plant, how the water will be treated before disposing of. Okay, so this type of it is also there in Kakinada city, probably for I don't know, right? So okay, I will stop here. Hello.
Okay.
Oh.